Hello everyone. So in this lecture we are going to discuss the questions from NET JRF December 2017 and question number is 26 from booklet code A. So question is from countable, uncountable, 1 and onto function. So what is the question? If f is a function from a set x to y be a function, then we have to identify which of following statement is correct. Your first option is if f is injective, that is 1 function, then there exists g from y to x such that f of g of y is equal to y for every y belongs to y. So first we have to identify this statement. Or similarly, second, if f is onto, then there exists g satisfying this property. Third is f is injective and y is countable, then x is finite. Or fourth is f is surjective and x is uncountable, then y is countably infinite. So let's start with this option. Since f is 1 function, so f defined from x to y already 1 function. So implies number of element in x must be lesser or equal to number of element in y. Now if there exists g from y to x, assuming that there exists g which is from y to x such that f of g of y is equal to y for all y belongs to y. So this implies the function f of g, which is defined from y to y, and with this help property f of g must be a identity function. And identity function is 1 and onto, implies g must be 1 and f must be onto. So this implies f is already 1 and f is all onto. So this implies f from x to y is 1 and onto. So this implies cardinality of x is the same as cardinality of y. But in this question, x and y can be any set in which f is a function from x to y, which is 1 function. So if we will take x set of a natural number and y which is set of real number, then we can define f of x is equal to x for all x belongs to m. This function must be a 1. Now if there exists g from y to x such that this property hold, then g is also 1. But r to n there does not exist any 1 function, or f is 1 onto, but x cardinality of x is countably infinite, cardinality of y is uncountable. So this one is an counter example for option 1. So your option first must be false option. Next come to second option. So your second option is if f is onto a surjective function, then there exists g which is from y to x such that f of g of y is equal to y for every y belongs to capital Y. So now again f of g, which is defined from y to y, is identity function, implies f is onto and g is 1 function. So already f is onto given. So this case can be possible, and we have already discussed that if f is a function from x to y which is onto function, then there must exist g function which is from y to x and it must be 1 function. So this we have to construct g such that g must be 1 and f of g should be equal to identity. So we have this set x and the another set y, and f is a function from x to y which is onto function. That is, every element of y, if we will write down b1, has a pre-image, say a1. Now pre-images can be more than one. So b, since function is onto, so assuming that the pre-images of b1 is a11, a12, and so on, a1k. So these all are pre-images of b1. Similarly, for b2, pre-images can be a21, a22, or a2r. These all are pre-images of b1. Since function is onto, so every element has a pre-image, or pre-images can be more than one. Now we have to construct a g function which is from y to x, and it should be one function. So let's define a new set z, which is a11, a21, a31, and so on. I am writing for countable set. You can prove for any uncountable set also. Obviously this z must be a subset of x. So basically, if a11 is a pre-image of a b1, we are picking one element from all of the pre-images. And if a21, a22, a2r, these all are pre-images of b2, then we are picking only one pre-image. Then this z must be a subset of x. Now define a function which is from y to z, and z is already subset of x. Now in y there are element b1, b2, and so on. In z there are element a11, a21, a31, and so on. Map b1 to a11, b2 to a21, b3 to a31. Then this is a g function. So basically, g of bi is equal to ai1. Definitely this g function must be a 1 function. Now if we will take a f for g, so for f for g, first g is defined from y to x. So this is a g function, and then f is defined from x to y. So in g, image of b1 is a11, and image of b2 is a21, image of b3 is a31, and in f, image of a11 is b1, image of a2 is b2, or image of a3 is b3. That is, this function f for g is identity function from y to y. So basically this B option is based on the statement, if f is onto function from x to y, then there must exist one function from y to x, and this one is the construction for the one function. I am discussing for countable set. You can easily discuss for uncountable set based on the equivalence relation. So your second option definitely true option. Now come to third option. Your third option is, if f is one function and y is countable, implies x is finite. So f is 1, y is countable. So f is defined from x to y, and it is a 1 function. So this implies number of element in x lesser or equal to number of element in y. Now y is countable, so x must be countable but need not be finite. It can be countably infinite. So C option definitely false option. Now D option, if f is onto and x is uncountable, f is onto and x is uncountable, implies y is countably infinite. So again, based on this given information, f which is defined from x to y, this is onto function, so implies cardinality of x must be greater or equal to cardinality of y. This set is uncountable, so imply this y can be countable, can be finite, or can be uncountable. So this does not imply y is countably infinite. So D option also false. So your final answer must be B answer.